I'm sure it'll be fine. I just haven't, yeah,
It's okay.
I haven't checked. Okay, so let's get started. Again, there's attendance up there. Make sure you sign in. I want to go back to a couple of those, kind of complicated domain problems that we had Monday. And I want to just, graph the functions on the calculator. We're certainly not graphing those complicated functions by hand, but I want us to compare, the domain we got with the graph, okay? And, there are the two things that can happen, okay? There are the kinds of functions, okay, that have square roots in them, okay? If you have a function with a square root in it, then, everything, the expression under the square root has to be greater than or equal to 0. And what happens graphically is that the graph just starts or stops, okay? So there's, this point where the graph starts or stops whenever you have a square root in your function. And then there are the kind that have x's in the denominator, okay? And what happens to those graphically is that at whatever x makes you divide by 0, you have a vertical asymptote for the graph. Okay, so I want to look at some of the complicated domain problems for Monday, and then just have the calculator graph them and, have us see if it makes sense. Okay, so for some of the domain problems earlier, let's graph the functions and see how the domain we found corresponds to the graph. Graph the functions on the calculator. Okay, so I'm just going to pick a few of them. G of x was the square root of 5 minus 2x over x plus 2. Okay? Now, we had, of course, a square root. Okay? I'm not going to do this over again, but, we had, of course, a square root. The expression under the square root had to be greater than or equal to 0. We solved that linear inequality, and we got that x has to be less than or equal to 5/2, 2.5. But in addition, the denominator can't equal 0. Okay, so in other words, x cannot equal -2. Okay, so the domain we got goes from -infinity to -2, not including -2, union, parenthesis, -2 to 5/2. Okay. Now, at x equals -2, we should expect a vertical asymptote. Okay, because x equals -2 makes us divide by 0. So that's what should be going on the graph precisely at, x equals -2. Okay, and then from the square root part, the graph should just stop. Okay, the graph should stop at x equals 5/2. So, I'm going to have the calculator graph it, but I mean, I know that the graph is going to have a vertical asymptote at x equals -2. Okay, -2 is not in the domain of the function. Nothing going on at x equals -2. Okay, I'll just label, so x equals -2. And then at 5/2, 2.5. Okay, now actually at 2.5, we have the square root of 0, which is 0. And then we have 0 in the numerator over something. So at 5/2, the graph actually equals 0. So I'm kind of expecting that to happen. And there's nothing going on, so no points to the right of 5/2. Okay, there are points to the left of -2. There are points between -2 and 5/2. And let me just type in the function and, have the calculator graph it and have it hopefully make sense. Okay, so square root of, I don't have a fancy calculator, so I got to do this, 5 minus 2x, and then close off parentheses, divided by, I have to wrap the x plus 2 in parentheses. Okay, I'll start with a zoom 6. Maybe I'll need a different window. Maybe that'll be okay. So, okay, there's a vertical asymptote somewhere, okay, and it had better be at x equals -2 because that's where we divide by 0. So we have, some sort of vertical asymptote here. Okay, so there are points on the graph to the left of -2. There are points on the graph to the right of -2. Nothing is going on at -2. And then my graph just goes down and stops there. It might be hard to see that from the graph, but if you go into trace, okay, now in this window you're not actually going to have a pixel be at 2.5, but okay, so at 2.34 we have a y value. If we were in a window like a zoom decimal window, if we're in a zoom decimal window, then the pixels are at every 1/10 of the way. So we can see that, okay, at 2.4, we got a y value. At 2.5, the y value is 0. And after 2.5, says 2.6, y equals blank, which means there is no y value on the graph. And if you look at your table, ooh, why am I way up there? If you look at your table, at x equals 2, there's a y value. Now, I can't see 2.5 in my table unless I change things. But at x equals 3, and anything actually after 2.5, I have an error because I'm taking the square root of a negative number. Okay? So, again, this is what the graph looks like. It stops here. That's the end of my domain. Okay, everything to the left of 5/2 is in the domain except x equals -2 because that makes me divide by 0. Okay, so knowing the domain can really help you do the graph. Okay, even if you had to graph by hand, which eventually we will. Okay, I want to look at our last example. Okay, g, that I guess I called little g of x, is the square root of x squared minus x minus 6. over x squared minus x minus 12, okay? And, you know, we had lots to work on. You know, we had to make sure that what's under the square root is greater than or equal to 0, and that what's in the denominator is not equal to 0, okay? And, you know, here we found out when we set the denominator to 0, we got x equals 4, as well as x equals negative 3. Okay, so from here we got x is not equal to 4, x is not equal to negative 3. And then from the square root, okay, by setting what's under the square root greater than or equal to 0, okay, which was a quadratic, i.e. nonlinear inequality, and we had to solve it by making a sign chart. We got the x's to the left of negative 2, the x's to the right of 3. So putting those together, we have the domain goes from negative infinity, then I had to exclude negative 3, union, exclude negative 3 to negative 2, because that's after negative 2 for a while, I'm going to have a square root of a negative number, okay? And then union for the other part of the quadratic inequality from 3 normally forever, but I have to exclude 4. Okay? So at these two x values that make me divide by 0, I'm going to have vertical asymptotes. At x equals negative 3, there's going to be a vertical asymptote. And similarly, there's going to be a vertical asymptote at x equals 4. Okay? And then, okay, there's nothing going on, like if I look at the picture of my domain, right, there's nothing going on between negative 2 and 3. So on that interval is completely empty space there. And that means at negative 2, my graph is going to stop. Okay, so my graph stops here. And then nothing goes on until 3. My graph starts up again at 3. Okay, so and at negative 2, okay, that's one of the numbers that makes you get 0 under the square root. You have the square root of 0, which is 0, so you're going to have 0 there. And similarly at 3, you have a 0 under the square root, so we have 0 there. And then we have a vertical asymptote at x equals negative 3. And another vertical asymptote at x equals 4. No points on the graph in between negative 2 and 3. Absolutely nothing going on. Okay, let me type in the function and see if it makes sense with what we think should happen. Okay, so square root of x squared minus x minus 6, closed off my under the square root, divided by, and then I have to wrap the whole denominator in parentheses, x squared minus x minus 12. Okay, I'll start again and assume 6. Okay, so I've got something going on over here. I got something going on here, and then actually it just stops. And then something going on here, and then vertical asymptote over there. It's hard to see what's going on the calculator. It's hard to see what's going on from -2 to 3. You might think it's just lying along the x-axis or something. But if you go into trace, where am I pointing to? Let's go backwards a little bit. Let me just go to that Zoom 4 window, even though, well, actually, that's quite nice. Sometimes Zoom 4 makes, when you go into trace, it makes the pixels happen every 0.1, which is nice. Sometimes you might need to make the Y min and the Y max bigger, but that won't mess up making the pixels happen every 0.1. So, okay, so where are we? Let's go back. Okay, so, well, let's go back to past -3. Okay, I'm way past there. All right, so I want to show in trace what happens when I get to -3. So I got -3.1, y is 3 point something. At x equals -3, y equals blank, okay? The function is undefined at x equals -3, and that's why we have a vertical asymptote at x equals -3. And then after that, we got points on the graph. When we get to -2, y is 0. Okay, that's from the square root. And then after -2, we just got y equals blank, which means in our table we got, a whole bunch of errors. Right, between -2 and +3, we have errors because we would be taking the square root of a negative number. Okay, back to the trace. Okay, where am I now? So, I got all these numbers, y equals blank. These numbers are not in the domain. From x equals -2 to x equals 3, I have nothing going on the graph. Complete empty space. Until I get to 3. Okay, at x equals 3, y equals 0. The graph's sitting there on the x-axis. And then I got points until I get to x equals 4. Again, it says y equals blank, but that's because you're dividing by 0. And that's why you have a vertical asymptote at x equals 4. And then after that, we got points on the graph. So it would be instructive for you when when you've gotten domains of these complicated functions, it would be instructive for you to type in the function on the calculator and look at the graph and make sure that it makes sense, okay? Again, wherever you have a square root, okay, your graph is going to start or stop at those values that make you get 0 under the square root. And wherever you have an x that makes you divide by 0, you're going to have a vertical asymptote on the graph. Okay? All right, so hopefully that will clear up what these weird domains actually mean. Okay, now the next thing I want to do in this section is graph some more functions, not as complicated as these, but graph some more functions by hand, okay? And, once we get the graph in front of us, we want to find the range. Usually the domain we can find just from the equation, but the range we really would need to have the graph in front of us. And along the way, we'll do some reviewing of certain kinds of equations, how to solve them. Okay. So graph the following functions. By making a table of values. But let's also find the y-intercept is easy to find. And let's find the x-intercepts, not just by stumbling onto them, but by setting up an equation and solving it. And then once we have the graph, find, well, the domain and the range. We probably already had found the domain. Okay, so f of x equals 3 times the absolute value of x minus 2 minus 9. Okay? Now, I'm going to make a table of values at some point. Okay? But let's just find our y-intercept and our x-intercept, or ceps. How do I find a y-intercept for any function whatsoever? Right, set x to 0, or in function notation, I can say f of 0. So f of 0 is 3 times the absolute value of 0 minus 2 minus 9, which is 3 times the absolute value of negative 2 minus 9. What's the absolute value of negative 2? Plain old 2. So 3 times 2 minus 9, or 6 minus 9, or I guess negative 3. Okay. So 0, negative 3 is the y-intercept. And you know, this is a function, so when you plug in x equals 0, you get one and only one y value, so one and only one x-intercept. Okay, now, what did I just say? One and only one y-intercept. Did I say that? Okay. In my head, I was already on to x-intercept, so I thought I might have said that. Okay, now, how do you find x-intercept or ceps in general?
Set y.
Okay, set y to 0, or, f of x to 0. So here I have 0 equals 3 times the absolute value of x minus 2 minus 9. Now, this is what's called an absolute value equation. Okay, absolute value equation. To solve an absolute value equation, first get the absolute value all by itself. Okay, so isolate the absolute value of x minus 2. Whatever is the absolute value, get